Indexes are basically data structures that database engines use to quickly find data. As an analogy, think of a telephone directory. Using a telephone directory, we can quickly find someone's phone number because contacts are sorted by their last and first names. This way, we don't have to go through every contact in the directory. Database management systems use indexes to find data in a similar way. Let's say we want to find customers located in California. Without an index, MySQL has to scan every record in the customer's table. This is not a big deal in a small table with a few hundred or thousand records, but as our tables grow larger, the cost of this query is going to increase dramatically. We can speed up this query by creating an index on the state column, and this is like creating a directory of customers sorted by their state. In this directory, or more accurately, this index, we only have the state of our customers and references to the records in the customers table. So MySQL can quickly find the corresponding customers using this index, and then it will read those records from the table. This is way faster than scanning or reading every single record in the customer's table. In a lot of cases, indexes are small enough that they can fit into memory. That's why it's much faster to use them to find data, because reading data from the memory is always faster than reading it from the disk. So indexes help us find data quickly, but they come with a cost. First of all, they increase the size of our databases because they have to be permanently stored next to our tables. Also, every time we add, update, or delete a record, MySQL has to update the corresponding indexes, and this will impact the performance of our write operations. For these reasons, we should reserve indexes for performance-critical queries. One of the common mistakes that a lot of developers make is that they add indexes at the time of designing their tables. You don't create indexes based on your tables. You create them based on your queries, because the whole point of using an index is to speed up a slow query. Adding an index based on the design of a table is like solving a problem that doesn't exist. So don't blindly add indexes on your tables, because this will increase the size of your database and slow down your writes. Now, internally, indexes are often stored as binary trees, but in this course, I'm going to present them as tables because it's easier to visualize and understand them. In case you're not familiar with binary trees, they're basically one of the fundamental data structures that computer science students learn at school. You don't really need to understand how binary trees work to work with database indexes. So, for simplicity, think of indexes as tables as I've presented in this lecture. Now let's see how we can create an index.